Hello, welcome. In this video, I would like to share an example of applying machine learning in a clinical context. Originally, it was a presentation from my master thesis in Intelligent Interactive System. It is a computational and visualization tool for investigating association between cardiac radiomics, risk factor, and clinical data. In this presentation, it starts from context, problem statement, and specific objectives, methodology, results, discussion, and future work. Context. As you may have known that in healthcare-related work, physicians, researchers, they have been studying to improve many areas such as disease prevention, disease detection, accurate diagnosis, risk assessment, and personalized treatment. With the related data such as disease data, MRI data, patient data, and risk assessment data. What kind of patient data are collected? For example, there are lifestyle, medical history, physical measures, environmental measures, imaging, and so on. And what kind of data we get from MRI? Let's see an example from cardiac MRI, which we can see as an image of the chip. But once its features are extracted, we get radiomics data, which is more useful in-depth for analysis. What do we have in radiomic data? It consists of shape features, statistic features, and textural features. So, the MRI is not just an image. It's now become a very high-dimensional data. Problem statement and specific objective. When data from a large number of patients, and each patient has a lot of information, with high-dimensional radiomics data, risk score, and disease, the data becomes big data. How can we find the association among them? In this thesis is present a computational and visualization tool for investigating association between cardiac radiomics, risk factor, and clinical data. Methodology. Software specification. The main function includes correlation exploration between radiomics, risk score, and clinical data, feature selection, data filtering, data stratification, statistical result visualization, risk score calculation, and cluster exploration. Software design. This is a web-based software. Why? Because it's easy to access. The only web browser is required. Responsive support for multi-devices, interactive, and easy to use. Visualization. It is data interpretation from table of data to plot and graph. Web framework and programming language were evaluated based on popularity, community, clean code, etc. Python was used at the backend due to the libraries cover all tasks in machine learning pipeline. But Python is not a web framework. In order to develop web application, Django Web Framework comes into play. The interactive tool for bringing insight to user was developed by Plotly.js. For a better look of user interface UI and speed up the delivery, jQuery, jQuery UI, and Bootstrap were used. User interface. There are three main parts of the design. First, data uploading. Second, dynamically display for the list of features and clinical outcomes based on the uploaded files. With this dynamically display, it is flexible for different datasets. Third, custom functions for displaying the association between the data, which are feature selection by attributes, the specified result represented by group mean value, Framingham score for the selected group, correlation between radiomics data and Framingham score, Furthermore, after radiomic features are selected, whether by implemented algorithm or manually selection, PCA and LDA plots are available for data visualization in 3D space. Result: correlation exploration between radiomics, risk score, and clinical data. In this project, the patient dataset was processed from UK Biobank data, which had been collected since 2006 from men and women in age range 40 to 69 years old. The data was selected from categories lifestyle, medical history, physical measures, and imaging. The process of work started from data pre-processing to make the data ready for analyzing, and this was the most time-consuming part of the project. These are sample results from the tool. Once the files are uploaded, the content will be automatically displayed here. From using multiple functions provided here, the correlation will show in bar charts for different contexts such as features mean value based on certified data, variance in the group, Framingham 10-year risk score, and the change of feature. Correlation between risk score and radiomic features. Feature selection. The feature selection was implemented by using XGBoost algorithm. Why? Because XGBoost is a new algorithm widely used in calculus computation. It supports regression and classification. It's fast, so it's possible for web-based regularization and control overfitting and stable result. How to use XGBoost feature selection function. In order to find the radiomic feature that highly correlated with selected clinical outcomes, the target should be selected first. In this selection, it means our target is male, whose age is in the range of 40 to 70 years old. Then click on the XGBoost feature selection button. Then enter the number of features and click on the Execute button. The result shows scores for training and testing. When the data type is numeric, the score is calculated by mean squared error. But when the data type is categorical data, the percent of accuracy will be shown here. Selected features are also displayed. The system will automatically select the features on the feature list based on the result. Data filtering. The target data can be flexibly selected. In this example, it means that the target is only male whose age is in range 40 to 70 years old. Data stratification. In order to stratify the data into small groups, intergroup level, number for bin or the interval is available when the data type is numeric. From this setting, it means: first, stratify the data by sex, to female and male. Then, group the data by range of age for every 10 years, which starts from age 40. Statistical result visualization. Plotly.js comes into play for this. Plotly comes with the function and toolbox compatible for each type of plotting. For example, to hide or show group of data, click on the feature at the legend area. Examples of functions in the toolbox are downloading image, zoom in, zoom out, pan, box select, lasso select, rotation, and so on. Risk score calculation. In order to understand the chain of cardiovascular condition, Framingham risk score for cardiovascular disease was used for calculating 10-year percent risk score. What is Framingham risk score function? It is the equation from regression with used risk factor data from Framingham Heart Study. It is gender-specific algorithm. The simplified version was used in this project, and these are the factors. Cluster explorations. Principal component analysis (PCA) and linear discriminant analysis (LDA) are used for visualizing patterns of data. PCA is unsupervised learning algorithm which represents the data in the direction of maximum variance, while LDA is a supervised learning and is for classification task. It represents the data by minimizing the distance within class and maximizing between classes. Here is the sample result from using PCA for data visualization and coloring the data points by gender. First, select the features. Then, select target output for coloring data point and click PCA plot. The result shows in 3D space. Sample result from LDA plot. Select features. In this case, the target group of patients is filtered by gender female. Then, color the data point by diagnosed result. Click on LDA. The result shows in 3D space. Online access is available here. Discussions and future work. There are 4 points I would like to discuss here. First, XGBoost feature selection evaluation. It is fast, high accuracy in binary classification, stable for feature selection. Second, correlation exploration. The linear correlation between radiomics data, critical outcomes, and risk score are found, which may help physicians and researchers for better understanding the change in radiomic features and the relation with health conditions. Third, the pattern of data are visualized by PCA and LDA. It helps users to understand the relation between groups of data, like the group in data are clearly separated or it is shown as a subset of one another. Fourth, Framingham risk score. It is important to note that Framingham risk score function was from target population in Framingham City. There are the studies said that it should be reclassified for a new target population for more accuracy. Limitations and future work. Thank you very much for watching.